Provably makes agentic workflows reliable in minutes. Agents are the new users of software. The main problem is they're operating as swarms, and if one of them makes a mistake, errors can propagate through. Downstream agents don't have a way to verify if the data that they're receiving is correct and complete. Specifically, I'm talking about when agents make tool calls. When they're calling an API or an MCP or they're executing tasks, they don't have a way to prove to the next agent or another agent downstream in a multi-hop scenario that they've actually performed the task. And this one has no way of verifying if a previous agent has actually done the task. And therefore, errors can propagate. Recent studies, like state-of-the-art, even using state-of-the-art models in early 2026, show that individual errors are very high in the 20s and 30 percentile range, whether it's hallucination or API calling errors. And then when you look at it as a whole workflow, the error possibilities are much higher. Now, at the moment, it takes many days to weeks to build reliable agents. And I'm going to give you an example of why this is the case. If you take this customer service chatbot, and this is based on a real example that we've seen. A user asks, can you check my last order status and the balance in my account? That question goes out to a customer service agent, which looks for the right tools and to find the answer. In this case, it's a Stripe MCP, Shopify MCP, and then an internal system. It comes back saying the order has been delivered, payment was successful, and so on, when actually Stripe and Shopify say something else. This can happen whether it's a single agent or a multi-agent. Sometimes these errors happen because the agent gets confused or it's trying to produce an answer in quick time and it just wasn't able to correct itself. The problem here is that the users see the error first. And the way this is normally dealt with is observability tools are deployed, and then those tools basically are basically logging the interactions between agents and different systems, and then either a human or you can use an LLM judge to find the errors manually or using these LLM judges, and then you classify the errors and then you can improve the model. The point is you have to do all of this plumbing. Secondly, you need the errors to happen. And thirdly, someone needs to classify them. And if you use the LLM judge itself can make a mistake. So there is like a quorum of LLM judges. This is a very token intensive, time intensive, and overall expensive process to go through. Now, what we're going to do with Provably is I'm going to switch to a real example. The way Provably makes agentic workflows reliable in minutes is that when agents talk to different backend systems, they must come back with the cryptographic proof that can prove to different agents internally or for itself to verify the source of its answers. And if it cannot prove the source of its answers, it cannot present it to the end user. And therefore, and because tool calls are very deterministic, you can have a very, very high accuracy rate here, whether it is a frontier model or an open source model. And here's a demo. This is a customer control panel that we built just to show off the idea. We have different customers here, Acme Corp and Wayne Enterprise, all these different customers. What you see is the name of the customer. They have some open tickets, some messages that they've sent in the past, and then some invoices. So I'm gonna go to Acme Corp and say, what plan is Acme on? We're using Claude Haiku 4.5. The model produces an answer, and then now the verification has happened. And this purple tick says that the workflow was able to verify itself, and therefore is passed the verification. And you can also look into it as an end user. You don't have to, but if you look into it, you can see the model took 3.4 seconds, and the Provably tools all took about 3 seconds. And what it has done is essentially verified that this answer has come from the CRM system. So it actually called a real tool. This was the input, and that was the response that it gave. And the proof extracted, basically, it proved that it extracted enterprise from the plan attribute, and it presented that answer. Now that's a simple use case, and you can really ramp this up in more complex scenarios where it's extracting different pieces of data from multiple APIs. Has Acme paid their April invoice? No, they have not paid their invoice. The invoice number is number 2, issued on the 1st of April, and it's still outstanding. And when you click on that, you can see that the billing invoice was called, and this was the input, and that was the response from the API. And there were 3 claims that are being backed by cryptographic proofs. No matter how many things are being proven, the provably time is actually around 3 seconds. It's pretty consistent. You can call multiple APIs. In the version that we have right now, if you call one API, it's 3 seconds, and then for each API, it adds more. But we're going to be releasing a version in a couple of weeks' time, fully open source, where you can call multiple APIs and you can verify all of them at the same time. It'll always be 3 seconds. And then if you run Provably locally, the actual verification time is about 200 to 300 milliseconds. So this can be really scaled up and really fast. But the point is, the end user has a reassurance verification has taken place. They actually don't need to go in and check all of this stuff. But I'm just sharing in the back end how this all works. Now, you're welcome to go and try this. We've shipped this Provably. So just go to github.com/Provably AI and then click on the verifiable data agent kit. And then there's a README. So just point your Claude at it and go and give it a try and build one for yourself and see how your model becomes more reliable. Your agentic tool calls become more reliable using verifiable data agent kit. Thanks for watching and look forward to your feedback.